Hello, everyone. My name is James Newton King, and today I'm excited to talk to you about gRPC on .NET. So, the agenda for today's talk: first, we'll give a quick introduction to gRPC for anyone who is new to it, and as part of that, I'll demo testing a gRPC app using a testing tool such as Postman. Then we'll take a look at what's new in .NET 7, and that will include performance improvements, a new feature called gRPC JSON transcoding, and gRPC support on Azure and how it's improved in the past year. So what is gRPC? It's a popular open source remote procedure call framework. RPC frameworks make it easy for apps to talk to each other. Now, gRPC is run by the Cloud Native Computing Foundation, the CNCF, and what Microsoft and the .NET team has done is we've written a new implementation of gRPC that uses the latest and greatest features in .NET, and we've contributed it to the CNCF. gRPC is cross-platform. It's supported by every major programming language, be it C++, Java, Go, Node, Ruby, Python, C#, Rust, you name it, there's an implementation for it. And these are all interoperable with each other. You could have an Xbox game written in C++, call a gRPC server in the cloud written in .NET. They can happily talk with each other. gRPC is contract first. That means the messages and methods and services are defined in a contract known as a protofile, and that is then used to drive code generation using tooling that the gRPC project provides. gRPC, it's not new. It was originally open source in 2015, but it's a union of two modern technologies, HTTP2 at the protocol and transport layer, and then protobuf as its serialization technology for producing very small, fast binary messages, and also the contract format. So protobuf is the language neutral syntax that you'll find in protofiles. Okay, with that, let's demo building our very first gRPC app. So what I'm going to do is come to Visual Studio and we'll add a new project and we'll choose to create a gRPC app from a template. So we include a basic Hello World gRPC template in the .NET SDK. This will create an app hosted in ASP.NET Core with an example service set up ready for us to use. So we'll create this. The first thing I'll do is I'll just update the log levels so we get a bit more logging while I'm demoing stuff to you. Okay, let's take a look at what we can find in our solution. So we've got this greet.protofile. This is the contract I mentioned to you earlier. This is where our messages are defined, our services are defined. You can think of the contract as kind of like an interface, and then there's an implementation for that interface. So the implementation is found in greet.service. So this will use all the types defined in that greet.proto, and this is where you place your business logic. So this is where you place a logic to handle an incoming message. You can respond to it, you can validate it, you can use it to call off to a database, save files to disk, and then eventually return a response. And then finally, we've got program.cs. That's the standard startup location where everything's wired up. So let's start off by taking a look at our greet.service file. So this is a standard C# class. We've got a constructor here. We're doing a bit of DI to inject a logger. We're not going to use that today. And then we've got this say hello method. So you can kind of think of a service as a controller, an MVC, and then a method, a gRPC method is like an action. So this particular method takes a request that returns a reply. So on that request, we have a name property. We're concatenating that with hello. We're sending that back to a message, and we're returning it to the client. So it's hello world. We give it a name. It'll say hello to that name. But looking at this type, this file, we have some types that are never defined anywhere in our solution. We've got greeter base, hello reply, hello request. Where are these types coming from? And the answer to that is code generation. So if we go to the definition of this greeter base file, we can see we've got an abstract base class being generated for us. It's got this say hello method, which is virtual, so we can override it. And then we've got a whole bunch of code to wire up routes and serialization. It all looks kind of ugly, but the beauty of code generation is it's writing this code so you don't have to. And we can confirm that it's all coming from code generation by looking at the header. We can see this is auto-generated, it's coming from the greet.proto file, and it's been generated by the Google protobuf compiler. So where has this been driven from? The answer to that is this greet.proto file. So this is where we're defining the contract for the APIs that our app's going to provide. So in this case, we're saying we're going to provide a service called greeter. On that service, we've got a say hello method, which takes a request, returns a reply, and then we've got our name and message properties, and these are typed to be strings. Okay, but how does Visual Studio and the compilation know to do the code generation? And that's wired up in our CS_proj file. So I've got this protobuf element that references greet.proto, and then we're specifying we want server code generation. So we want a service-based type that we can then implement in our greeter service. An alternative value here could be client, in case you want a strongly typed client to call the gRPC service. And then we've also got this package reference. So this is bringing in the gRPC server implementation along with the serializer and the tooling. So if we run this app and then browse to it, we'll see what happens. So let's just open up our console app. So this is standard Kestrel logging to let everything know it's running, and it's launched on this port 7160. If we browse to this, we get this message saying communication with gRPC endpoints must be made through a gRPC client. So unlike REST, where you can just navigate to a URL, enter some a path and some route parameters, maybe some query string values, and get back some JSON, with gRPC, both the client and server need to know about that greet.proto file because it's contract first, and our browser doesn't know anything about it. Now, there are a couple of ways we could test our client, our server that we've just created. We could create a .NET client using that greet.proto file. But what I'm going to show you today is using a testing tool called Postman to invoke our server. So Postman is probably all pretty familiar to a lot of you. It's always had great support for invoking RESTful HTTP APIs and has all kinds of advanced features. But recently it's added support for gRPC requests. So in Postman, we can say new gRPC request. We can then specify a URL that we want. So this is what we just entered up here in our browser. We're using HTTPS, so we'll click the lock. And then if we choose select method, we don't get the methods to get. We don't have say hello on this dropdown, and that's because Postman still doesn't know about that pesky contract file. We need it to let it know about greet.proto. Now we could choose to import the greet.proto file, but what I'm going to do is I'm going to set up something called gRPC server reflection. So server reflection is kind of like Open API for RESTful APIs. So Open API is a JSON file. It's located on your server, and it has definitions about all the services that your server provides. gRPC server reflection does the exact same thing, except it is a gRPC service providing information about other gRPC services. So we want to set that up on our server, and there is excellent support for it built into gRPC and .NET. And I will show that off to you right now. So first thing we're going to do is we're going to add a new package. So this is the server.reflection package. Then in our program.cs file, which we haven't looked at yet, we're going to add a service. So we're going to register some services with DI. So just like we're registering gRPC, now we're registering some additional services for gRPC reflection. And then finally, we're going to register map a gRPC service in our HTTP pipeline. So previously, greeter service was registered, so we were able to call our implementation here. We also want to register our reflection service. Okay, so that's all we need to do. If we now run our app again and we go back to Postman, we can click try again. And when we click that, Postman client goes off to the server. It downloads the available information about potential services. So we've got one service here and then one method. And we can now start using this to invoke our gRPC service from our client. And we can verify that by taking a look at the logs that get written by our Kestrel app. So we can see a bunch of HTTP requests have gone off to this server reflection service, and it's downloaded reflection info, and then Postman has used that information in the client to make our call available. So Postman knows about the messages that we send and receive, so we can click generate example message and then enter the message we want to send. So let's say .NET Conf 2022. Although I'm entering JSON here, this is just like a visual representation. Postman will convert it to protobuf when it sends it off to the client, off to the server. So we just click invoke, and we can see our name specified here, went off to the server and was concatenated with hello, and our server was invoked. And again, we can verify that by taking a look at our server logs. We can see that our say hello method was invoked and it called off to this say hello service, and we got a result back. So the great thing about gRPC and server reflection is once you have it set up, it's very productive to work with it. So if we want to add a new gRPC method, let's call it gRPC new method. Click save there. Code generation will automatically run, so we just need to override our new method. And we'll just copy and paste the previous implementation, and we'll just modify this slightly. Say hello new method, cool name equals this. We run our app. We go back to Postman and we choose refresh. Our new method is immediately available. We can choose it and we can invoke it. So that's how fast and iterative and productive gRPC can be by combining features like contract first, code generation, and tooling with gRPC server reflection. So a quick overview of what we just did. We created a server. We set up server reflection, only took a couple of seconds. And then we configured our testing tool to use that reflection. Usually this is just as simple as entering that address. The endpoint for server reflection is known, so tooling will just go off and check to see if it's available, and if it is, it will just automatically use it. Now, I demoed using Postman. Postman has a lot of features. Some of them are commercial, so keep that in mind if you want to use it. An alternative free open source tool is something called gRPC Web UI. And if you want to use the command line, gRPC curl lets you invoke gRPC services from the command line and get responses back. So let's talk about what's new in gRPC for .NET 7. Every year we try to make gRPC faster, and we've made some great improvements in .NET 7. Now, gRPC runs on HTTP2, so high performance in Kestrel's HTTP2 stack is critical. A long known issue to the ASP.NET Core team is a bottleneck when writing a HTTP2 response on a busy connection. Now, the way HTTP2 works is there are multiple requests running in parallel simultaneously on one TCP connection, and this is called multiplexing. However, only one thread can write to a connection at a time. That means we need to limit access to one thread, which was previously done with a simple C# lock. Now, locks are a great choice for thread safety a lot of the time, but in this situation, the lock had a lot of contention. There were dozens of threads fighting over it, and this was hurting performance. The way I like to imagine it is perhaps there's a small door and there are dozens of people trying to get through it simultaneously, and they're all pushing and shoving each other out of the way, knocking each other down. It's a very inefficient and wasteful process. So what we did in .NET 7 is we switched that lock to instead be a queue. Instead of fighting over a lock, threads would now line up in an orderly fashion, place some work on the queue, potentially go off and do other work while they're waiting, and then get notified that the write is complete and they can resume working with the request. So this CPU re-architecture saved CPU cycles from fighting over that lock and better utilized machine resources. Now, in a benchmark, we saw a server streaming benchmark. We saw an 800% increase in requests per second after this change. Now, this particular benchmark really stresses that lock. It's probably a worst case scenario. But even in more typical gRPC and HTTP2 usage, we still notice a nice improvements after this change in .NET 7. Another improvement is HTTP2 upload speeds. They're now much faster when uploading large messages and there is latency. So HTTP2 back pressure was limiting upload speeds when there's latency. The reason for that is the client would send a burst of data to the server. The server would say, hey, slow down. I can only handle so much data. The server would then process that data and then send a notification to the client that it can resume sending. Unfortunately, because of latency, it means there is a pause when sending and receiving data. So you can imagine data being sent in like bursts in a start-stop fashion. So what we did in .NET 7 is we increased the buffer sizes to find a better balance between memory usage and throughput. So previously, uploading a 100 megabyte file in .NET 6 would take about 27 seconds. In .NET 7, there is a 6-fold improvement. Now it's just a bit over 4 seconds. Finally, I'd like to talk about a .NET gRPC performance results benchmark from a community-run benchmark. Thanks to the great improvements in .NET 7, from low-level API improvements and the BCL, improvements to JIT, improvements to profile-guided optimization, all the way up to major re-architectures in our HTTP2 layer, .NET performance now meets and even exceeds really fast frameworks like Go, C++, and Rust when it comes to gRPC performance. I think this is a real testament to the kind of performance you can get out of .NET and also the quality of .NET's gRPC implementation. So gRPC JSON transcoding is a major new productivity feature in .NET 7. It's an extension for gRPC that allows a service to act as both a gRPC API and as a RESTful API at the same time. JSON transcoding is useful for anyone who wants to provide both types of APIs to their clients without having to build them twice. You don't want all that duplication of building things once with REST, once with gRPC, and then having to maintain them forever. Wouldn't it be great if you could just do it once and it worked for both? And that is what gRPC JSON transcoding allows. So let me demo this amazing feature. So we'll take our previous app and we'll extend it to include gRPC JSON transcoding. So again, we're going to add a new package to our CS_proj file. So we're going to add the gRPC JSON transcoding package. Then in our program.cs file, we're going to add a new service. And then we're going to add a couple of new proto files to our solution. So the reason we're adding these new proto files, and these are located, these are annotations.proto and http.proto. The reason we're adding these new proto files is we want to add some annotations to our say hello method to specify how it maps to a RESTful API. Like we need to specify a route to be able to call this. So after including these files, we then want to import one of them. So we're going to call import Google APIs annotations.proto. And then finally, after that, we'll just comment out the previous method. We're going to add the annotation to it. So the annotation is this particular bit of code down here. You can think of an annotation like an attribute in .NET. It's like metadata we're adding to the call. So in this case, the metadata we're adding is we're saying, if you want to invoke this call with HTTP, this is the route you use to call it. So it is a get route, it is v1 greeter, then this route parameter of name. And this name route parameter, it maps to the request property. So name down on hello request. So whatever value we enter here will get mapped down to here, and it will be used when we invoke our gRPC service via REST. So theoretically, if I've done everything just right, we'll compile our app. That's succeeded. And let's launch it again. And we'll come back to our browser. So previously, we got this warning saying we need to use a gRPC client. Let's see if we can now use REST. So we'll type in v1 greeter and then .NET Conf 2022 and success. We can see our GET request is now returning JSON from our protobuf gRPC endpoint. And we can verify that again by taking a look at the logs. Our request came in, it was a GET request to that URL we just specified. It got mapped to that gRPC endpoint, and then it returned a response. And in this case, the response was JSON rather than protobuf. So that's pretty cool. So this is just a very simple example of an annotation. You can also support post, you can support multiple route parameters, you can support binding query parameters, incoming JSON bodies, all kinds of verbs, get, put, post, delete, you name it, you can do it. And once you have JSON transcoding set up, it's very easy to add new methods. So we can just add greeter new method, and we're already set up and ready to go. So REST is great. The thing which takes RESTful APIs to the next level is OpenAPI. And what I'm going to show now is adding OpenAPI to our transcoded methods. So again, coming back to our CSproj, we'll add a new NuGet package. This one is gRPC.swagger. We'll add some new services to our startup file, program CS file. And we'll add some Swagger middleware, some Swashbuckle middleware. So this middleware will be familiar to anyone using Swashbuckle. We're going to register use Swagger and then use Swagger UI. Now, if I launch this and come back to it with the browser, I can now navigate to Swagger and I get the Swagger UI experience. And I can see my 2 endpoints are showing up. So I can come in here and I can invoke it just like you usually would. Hello.net and click execute, and we get back our message. And also, if we take a look at our swagger.json, it's just your standard Swagger, except instead of talking to a RESTful endpoint written with minimal API or MVC, in this case, we've got a RESTful API written with gRPC. So that's gRPC JSON transcoding. It's a very cool feature, but also very powerful, simple to easy to use, and a great productivity boon if you want to serve both gRPC and REST at the same time. So let's do a quick overview of how it worked. Imagine we've got a gRPC client that's talking protobuf. We use a google.protobuf serializer to deserialize to our hello request, and then we invoke our method. Imagine we've got a RESTful API client. It's got a custom route, which is got a route parameter. We bind that to hello request. We invoke the same method, and we're good to go. And even though I just showed off invoking it with REST, there's no reason you can't still keep using protobuf to use it at the same time. It's not one or the other, it's both at the same time. All right, finally, I'd like to talk about gRPC in Azure. I'm happy to say gRPC is now fully supported on Azure App Service. This request was ASP.NET Core's most commented on and voted on issue, and it's great to be able to get that done and mark it as closed. The actual work to do this was a joint project between the Azure App Service team and the .NET team. What we did together was we replaced one part of the Azure App Service infrastructure, this thing called a App Service front-end role, and we replaced it with YARP, which is a proxy toolkit that runs on top of ASP.NET Core, and in this case, we're using Kestrel. It means that we can fully support gRPC because Kestrel has great support for HTTP2. There was an 80% throughput improvement, which is great. Potentially, we can decommission the number of proxies we have, create greener data centers by using less resources and energy. And also, because Kestrel has great support for HTTP3, it provides a gateway for future features to get added to Azure App Service. That's all I have time to talk to you about today. There's great documentation available for gRPC on our docs website. Everything I've talked about, including testing with gRPC server reflection and JSON transcoding, is documented here. And there are also many examples available on the gRPC.NET repository, including gRPC reflection and transcoding. So thank you everyone for joining today. I hope you're all excited about gRPC on .NET, and I can't wait to see what kind of apps you make. Back to the studio.